Hey everyone, welcome back to another video of SQL series. In today's video, we are diving deep into the backbone of database integrity. That is, we're going to understand what is SQL constraint, what are the different types of SQL constraint, and what is the difference between unique and primary key constraint. So all these things we're going to cover in this video, but before that, as a prerequisite, you can watch the second video of SQL series, that is on table creation part, so that you can understand the following constraint very well. And link you can find in the description box. Now let's get started with the constraint part and first understand what is meant by SQL constraint. In a simple language, a constraint in a SQL is like a rule that we set for a column or group of columns in a table, and it ensures that the data stored in those columns follows certain guidelines or restrictions and maintaining the data integrity and the data consistency. That means if column satisfies that particular rule, then and then data will get inserted or updated in this particular column. These rules can include conditions like ensuring the column cannot have null values, column can store only unique values, or defining the relationship between tables. The constraints define the conditions that data must meet to ensure accuracy and reliability within the database. Let's explore each of the mentioned constraints with easy to understand definition and detailed explanation along with example using SQL code. Number 1, we have not null constraint. The not null constraint ensures that a column cannot contain the null values. It enforces to have a values in the column, that means values other than the null value. So basically this rule is applied to a column where mandatorily we required some values and don't want any blank or null values to be stored. So we have two ways to apply not null constraint. The first one is the not null constraint can be defined during the table creation, or the second way is if table is already created in the database, then not null constraint can be added later on by using alter statement. Let's take following example of employees table and we'll apply not null constraint on a first name and the last name column. This is the first way to apply not null constraint on the column during table creation. We can see the syntax. So here in this example, we can see by giving not null after column definition, we are saying that the first name and the last name column cannot contain null or blank values as per the rule of not null constraint. The second way is to apply not null constraint is altering a not null constraint after the creation of table. So above we have understood how to add not null constraint at the time of table creation, but let's say if we have already employees table present in the database, then how can we add not null constraint to a particular column? And that's where this alter statement is used to add the constraint after table creation. As you can see here, the given syntax alter table employees. So here we have age column added with a not null constraint. That means we cannot store null or blank values going forward. Number 2, we have unique constraint. The definition is like that the unique constraint ensures that all values in a column or a set of column should be unique. Means no two rows can have the same value in the specified column. That is, values cannot be duplicated. So we can have many unique constraints in a table. That means we can apply unique constraint on many columns. We have two ways to apply unique constraint, likewise we had for the not null constraint. So during table creation, or and the second is if table is already created, then using the alter statement. So first we can see how unique constraint is applied on a single column. So we have this syntax. So by specifying unique after roll number column, we are saying that the roll number cannot duplicate and it will always be unique. And the second is the application of unique key constraint on a multiple columns. So we have this syntax, and by specifying UC underscore student as a constraint name as a unique constraint on the roll number and exam ID column, we are saying that the combination of roll number and the exam ID will always be unique. Now move on to the second way, that is altering a null constraint after the creation of table. So above we have understood how to add the unique constraint at the time of table creation, but now we can see if employee table is already present in the database, then how can we add unique constraint to a particular column by using alter statement. So with the help of following mentioned alter queries, we can add unique constraint on a single as well as on a multiple column. So here we can see roll number and the exam ID column is added with a unique key constraint. That means we cannot store duplicate combination of roll number and the exam ID going forward in this particular column. Okay, so let's say example, if roll number is 10 and the exam ID is P123, then we cannot store this combination of 10 and P123 again in this particular column. so that this combination should be unique, as each student has the unique roll number and it will never be duplicated. We can also drop this constraint. Suppose business requirement has changed and they no longer want this constraint to be added, then we can easily drop this constraint using this below syntax. Number 3, we have primary key constraint. The primary key constraint uniquely identifies each record in a table, and primary key constraint can apply on a single column or the combination of multiple columns in the table, and that is called as composite primary key. The primary key constraint is the combination of unique key plus not null constraint. Means primary key column values cannot be null and has to be unique. That means it cannot be duplicated, like we had it for the unique key constraint. We have 2 ways to apply primary key constraint: during table creation, and the second is after table creation using the alter statement. Let's see first way. Under this, first we can see how primary key constraint is applied on a single column. We have the syntax. The syntax says that the order ID will always be unique, that is never be duplicated, and always be not null, that is null values will never be stored inside order ID column, because it's a combination of unique plus not null constraint. Now we can see the primary key constraint on multiple columns. Above syntax says that the combination of order ID and the custom ID will always be unique, that is it will never be get duplicated and always be not null. So here we have defined composite primary key between order ID and the custom ID columns. Now move on to the second way and see how we can alter table using alter statement and create the primary key constraint if table is already present in the database. So with the help of following mentioned alter queries, we can add primary key constraint on a single as well as on the multiple column. And to drop above primary key constraint, we can use the below syntax. Now see the difference between unique and the primary key constraint. Unique constraint ensures no duplicate value getting stored in a column or in a group of columns. That is complete uniqueness it maintains. On the other hand, primary key constraint is the combination of unique key plus not null constraint. That means no duplicate and no null values are allowed here. And if you talk about the not null values to be stored, then unique constraint allows only one null value to store in a column or group of columns, but not more than one, because for more than one it will consider it as a duplicate. And on the other hand, primary key constraint not allowed any null values to be stored. Number 4, we have foreign key constraint. The foreign key constraint establishes a relationship between the two tables, enforcing referential integrity. The foreign key is a column or a group of columns in one table that refers to the primary key of another table. That is, it ensures that the values in a column or set of columns in one table matches values in a corresponding column, usually the primary key in another table. The table with a foreign key is called as a child table, while the reference table with the primary key is called as the parent table. So we have 2 ways to apply foreign key here. Likewise, we had it for first 3 constraints. First one is during table creation, and the second one is after table creation by using the alter statement. So before understanding the ways to apply foreign key constraint, we'll first understand the relationship between the foreign key and the primary key. On the right side, we can see we have customers table, and on the first column of customers table, that is on customer ID, the primary key constraint is applied. And if you look at the left side table, that is order table, we can see the same customer ID column we are using here, that is present as a primary key column in the customers table. And that's where I have said that the table with the foreign key is called as the child table, while the reference table with the primary key is called as the parent table. Now let's see first way. Under this, first we can see how foreign key constraint is applied on a single column. So the given syntax says that the customer ID column, which is present as a primary key column in the customers table, we can make use of that in the orders table as a foreign key constraint or foreign key column. And if you talk about the foreign key constraint on a multiple column, then the given syntax says that the customer ID and customer name column, which is present as a composite primary key in the customers table, we can make use of that in the orders table as a composite foreign key column. Okay, so now move on to the second way and see how we can alter table using the alter statement and create the foreign key constraint if the table is already present in the database. So with the help of following mentioned alter queries, we can add foreign key constraint on a single as well as on the multiple columns. And we can also drop this composite foreign key constraint using this given syntax. Number 5, we have check constraint. The check constraint specifies a condition that must be true for each row in a table. It ensures that the value entered into the column satisfy the specific condition. For example, let's say in the employees table, if company wants to keep the details of the employees and they kept one condition in that table that only keep the employees details which employees having the age greater than 18, then in that case we can make use of this check constraint here. So here also we have two ways to apply check constraint. First one during the table creation, and the second one if table is already created, then by using the alter statement. Now we can see first way. Under this, first we can see how check constraint is applied on single column. So above syntax says that the employees table only keep those employees whose age is greater than 18. And for multiple columns, the syntax says that the employees table only keep those employees whose salary is greater than 0 and age is greater than 18 years. Okay. So now move on to the second way and see how we can alter table using the alter statement. With the help of following mention alter queries, we can add check constraint on a single as well as on the multiple columns. If you want to drop the composite check constraint, then using this below syntax, you can drop the constraint. Number 6, we have default constraint. The default constraint specifies a default value for a column when no explicit value is provided during the insert operation. So here also we have two ways to apply default constraint. First one during the table creation, and the second one if table is already created, then using the alter statement. Now let's see first way. Under this, first we can see how default constraint is applied on a single column. The given syntax says that the employee table stores a default value 0 for a column discount when no explicit value is provided during the insert operation. And for multiple columns, the given syntax says that the employee table stores a default value unknown for a columns when no explicit value is provided during the insert statement or insert operation. Okay. Now move on to the second way and see how we can alter table using the alter statement. So with the help of following mention alter queries, we can add default constraint on a single as well as on the multiple columns. To drop the default constraint, we can make use of the below syntax, that is we just need to mention the default as a null and default constraint will get removed. Thanks everyone for watching this video. If you like the video, please hit the like button and don't forget to subscribe the channel.